So, what's really happening? Removing starch size from cotton involves two very similar polymers. The polymer amylose is a main component of starch, and the polymer cellulose is a main component of cotton. Both amylose and cellulose are made up of many repeating units of a simple sugar called glucose. This is the same glucose that your body uses for energy, and in fact, when you eat a starchy food like bread, enzymes in your body will help chop up the amylose in the bread and then turn it into glucose to give you energy. But we can't eat cotton for food because we don't have the right enzymes to chop the cellulose apart. One molecule of glucose can form a ring structure that can be connected in two different ways. In the drawing of the glucose structure, when the blue OH group, called a hydroxyl group, is pointing downwards, this means the OH group is in the alpha position. In this position, one glucose unit can form chemically bonded alpha linkages with other glucose units to form amylose. These alpha linkages between the repeat units cause the polymer to form a coiled helix, like a spiral chain. In some other components of starch, the chain can also have branches. Then the polymer is called amylopectin, but we won't talk about that here. When the blue OH group points upwards in the chemical structure, this means that the hydroxyl group is in the beta position. When glucose units form chemical bonds with other units in the beta position, the resulting polymer is cellulose. The beta linkages make the cellulose polymer chain stretch out like a straight rod, and this allows cellulose to pack together tightly to make very strong fibers. Your body doesn't have the right kind of enzymes to degrade cotton, so we can't eat it for food. The type of linkage is very important because it drastically changes the properties of the final polymer. Removing starch from cotton fabric during desizing is a key step in fabric processing because starch makes the fabric stiff and can prevent uniform dyeing and finishing of fabrics later. Amylase enzymes are excellent for removing starch because they selectively target only the alpha linkages between glucose units and amylose. To remove starch from cotton, it's best to use a method that will leave the cotton fibers undamaged while completely removing the starch. When the amylase enzyme encounters the beta linkages in cotton, it will ignore them because the straight cellulose polymer has the wrong shape. When the same amylase enzyme encounters an alpha linkage, however, it can fit around this link, allowing it to break it by a chemical reaction called hydrolysis. Amylase enzymes catalyze the degradation of starch into glucose molecules. The reaction does require water to fill in the necessary atoms where the chemical bond was broken. In this way, starch is removed during the textile process of desizing with amylases without damaging the cotton. To check if the starch was removed, a liquid solution of iodine can be dropped onto the treated fabric. Iodine turns blue in the presence of starch and stays yellow if there is no starch present. This is a visual test to prove that the amylase enzyme is able to remove all of the starch from the fabric.